In this tutorial, we are going to discuss about the versatile nature of carbon. Versatile means that is in multiple ways how the carbon behaves. The tendency of carbon atoms to achieve 8 electron system, because we know something about the stability of atom based on the octa electron, that is octet rule. We used to call it octet rule. Octet rule. So according to this rule, any element which has 8 electrons around the nucleus will be stable. So this is known as Lewis octet rule. So the tendency of atoms to achieve 8 electron, octa means 8, in their outermost shell is known as Lewis octet rule. You just look at any atom. So in the first, this is shell number 1. We can call it K shell, and this is L shell. It can also be represented by the number 1, first orbit, second orbit. And this is the third orbit, that is M shell, third orbit. We have in the first shell, that is 2 electrons, 1, 2. In the second shell, you have 8 electrons. So likewise it goes. And if such electrons are, that is 8 electrons are surrounded, then we can say it has achieved the stability. So every element, every molecule, they try to achieve this stability. So electron sharing takes place in order to achieve a stable electronic configuration. Now let us consider the molecule of methane. It's represented by CH4. Methane is represented by CH4. So there are 4 CH bonds and with 4 hydrogen and 1 carbon. So this is called the Lewis dot structure. We know the valency of carbon is 6. So the valency of carbon 6 is, we can write down in the first shell it contains, that is 2 electrons, and in the second shell it contains, that is 2s2 and 2p2. So it is called s orbital and it has s and p orbital. So this is shell K, or you can call it first orbit. Similarly, L shell, that is second orbit. So as far as carbon is concerned, this is the outermost shell, that is L shell is the outermost shell. So how many electrons are there? 4 electrons. So we can put, that is this 4 electrons as a dot. 1, 2, 3, 4. And what about hydrogen? Hydrogen has got only 1 electron. So you can mark it as even, that is into. So hydrogen. There are 4 hydrogen. So you can put 4 hydrogen. Is it not? Now we can share the pair of electrons. So 1, 2, 3, 4, like this. Okay. So therefore you are able to get CH4, right? Then, so since the carbon is satisfied with the single bonds, 4 single bonds, so they are called saturated carbon groups or saturated hydrocarbon, because carbon and hydrogen are present, so they can be called saturated hydrocarbon. Okay, take down saturated hydrocarbons. Then let us consider the next one. So in this case, probably that is in the ground state. I'm considering the same methane molecule at ground state. That is, ground state means without the approach. When the that is, four hydrogen atoms are at a distant place, afar, far away. Then they are in the ground state. They don't get excited. So these four electrons are available in the outermost shell. Similarly, these four hydrogen, they have their own electron. But by the approach of these four hydrogen, the carbon get excited and they get shared with the hydrogen as a bond. So CH4 bond, CH and here CH. Okay. So likewise they form a molecule. So there are four CH covalent bonds as I already mentioned. Okay. So similarly we can consider ethane. So ethane is represented as C2H6, that is CH3 bond CH3. So when you consider this, now let us have the same carbon with its own four electrons in the ground state, and this carbon also has four electrons, and all these are hydrogen, they have only one electron. Okay. Now when they approach each other, what happens? They form a bond like this. Okay. So here there are CH bond, another CH bond, another CH bond. So there are three CH bond. Here, fourth one, fifth one, sixth one. So you can say there are CH, six CH covalent bonds. And we must ensure the valency of carbon as 4, that is tetravalent. So 1, 2, 3. What about this? So this is formed as CC covalent bond. So there is only one CC covalent bond. But when you count all these bonds, in fact, that is when you count the number of electrons, for instance, let us consider this carbon, it has got 2, 4, 6, 8. So 8 electron system is there. Similarly, this carbon achieved 8 electron system, is it not? So that way they attain the stability. Are you able to understand this? So you just look at it. So here we have shown the CH bonds in a red oval, shapes, and here CC bond in the blue or green circle. Okay, and as we already mentioned, that is each carbon has achieved 8 electron system, 8 electron system. As far as hydrogen is considered, it has achieved a 2 electron system. So thereby they have achieved the stability. Do you understand? Okay. So the stability part of it is very important. Okay. So 8 electron system, right? Then in the case of unsaturated hydrocarbons, as in the case of ethene, ethene is represented as CH2 double bond CH2. So in this case, we have, let us put similarly C. How many electrons are there? 4 electrons. Is it not? So 1, 2, 3, 4. And similarly here 1, 2, 3, 4. What about hydrogen? Hydrogen is here. Another hydrogen is here. And here another hydrogen. Here another hydrogen. Its own electron. Now we can pair this. So CH bond, or you will follow another CH bond, covalent bond. But you can find here 2 CC bond. Okay, so that is represented as a double bond. Okay, so this is double bond. So ethene has CC double bond, out of which one is sigma bond, another is pi bond. And what about this one? CH sigma bond. This is also CH sigma bond, CH sigma bond, CH sigma bond. So in this case, there are 1, 2, 3, 4. So 4 CH sigma bonds. Okay. And what about the pi bond? That is, we have one CC, okay, CC sigma bond and one CC pi bond. So together it forms a double bond. Do you understand? And let us consider ethane. In this case, we have one sigma bond and two pi bond. And here CH sigma bond, CH sigma bond. So we need to identify ethane. Ethane is simply represented as a molecule, as a molecular formula C2H2. Similarly, ethene C2H4. Okay, so let us consider this. Now we have 2 CC sigma bond, and what about another sigma bond, that is you have I'm sorry, that is a CH. So there are 2 CH sigma bond and one CC sigma bond and two CC pi bond. So they together form a triple bond. Do you understand? So here, as I already mentioned, in the case of ethene, we have that is CC double bond. Are you able to understand this? So covalent bond in ethene, and thereby they achieve the what 8 electron system. Let us see how they achieve the 8 electron system, stable electronic configuration. For instance, carbon, we have one electron, and here 2 electron, and take the hydrogen electron also. Now you just count it 2, 4, 6, 8. So they have achieved 8 electrons. Okay, and similarly 2, 4, 6, 8. So 8 electron. What about this hydrogen? They have 2, 2, 2. So they have 2 electrons. Okay, so you must always check this electronic configuration. Okay, after the formation of the molecule, right? Then, and there is a tendency of carbon, it is called catenation, chain forming tendency. So chain forming tendency of carbon is called catenation. It can form chains like this, long chain. This is a 4-membered chain. In case of butane, CH3, CH2, CH2, CH3. Is it not? So you can write like this, CH3, CH2, CH2, CH2. So there are CH3. So this is represented in a zigzag manner. CH3, CH2, CH2, CH3. Okay. So it means C4H3252 plus or 3, 10. So C4H10, which is nothing but butane. And similarly, they form 5-membered chain. So 5-membered chain in case of pentane. Okay. So this is butane. In case of pentane, they form 5-membered chain. So this is the pentane. Penta means 5. So pentane. And similarly, they can elongate their chain like this. So this is the 6-membered chain. So that is known as hexane. And similarly, it can go, increase like this, a long chain. Okay. Decane means C10 and then H22. So such catenation, chain forming tendency is very popular in carbon. Okay. So what is catenation? It is a property of a direct bonding between atoms of the same element. Now let us talk about once it forms as a chain, it can also form sometimes branches. Okay, so in the case of branch, let us discuss about branch. Let me say carbon, carbon, carbon chain. Now they can form a branch like this also. So in that case, now fill up this CH3, CH3. So 3 plus 1, 4, 3 plus 1, 4. And what about this? Only CH. Okay. And here CH3. So this is branched. Okay. So this is called, what is this? Propane, where a methyl group is branched. So it is called N. Actually, that is methyl, 2-methyl, because the position should be indicated. We'll be discussing in detail about this in IUPAC nomenclature. So 2-methyl, what is that? Propane. Okay, so this is branched. And now when you consider this chain, it may go on increasing. Sometimes the terminal chain may close as a ring. So this is called a ring closure. So this is a ring structure. Okay, so ring structure means 1, 2, 3, 4, 5. So this is pentane. It is cyclic nature. So it is called cyclopentane. So such type of hydrocarbons are called cyclic hydrocarbon, cyclohydrocarbon, cyclic hydrocarbon. Okay, they can be called cycloalkanes. If it is alkane, cycloalkanes. And the same tendency is exhibited in sulfur also. So sulfur has got the crown-like structure. So they involve 8 atoms. So what is atomicity of sulfur here? 8. Okay, so 8 sulfur, they can form like a crown-like structure. Okay. So basically the organic compounds can be classified into aliphatic and cyclic. So the aliphatic here, it is branched and straight chain. The same organic compound, that is hydrocarbon, they can also be available as a cyclic one. In that case, it is cyclic structure, cycloalkanes you can say. And there are some aromatic compounds also. They are benzene based compounds. And there are some heterocyclic. Hetero means a different. So in a chain, there will be a different atom occupying. So we will discuss about this. So how the organic compounds are classified? Basically, it can be classified as aliphatic hydrocarbons, then cyclic structures. Aliphatic here branched one and straight chain one. And here, if it is a cyclic, so this is called alicyclic. We can call it alicyclic. Alicyclic means not this one. Here, alicyclic, aliphatic cyclic. Okay, aliphatic and cyclic. So it can be called alicyclic also. And this is aromatic and this is hetero. Hetero means different. So cyclic hydrocarbon with, so normally they form the cycle ring-like structure only with the carbon. Here there will be a different atom occupying in one position, and that is why it's called heterocyclic. Let us consider this aliphatic hydrocarbon. So this is straight chain and branched. In straight chain you have N-butane. So N-butane can be represented as CH3, CH2, CH2, CH3. So this is known as N-butane. So N-butane, this can also be represented methyl, ethyl, propyl, butyl. So butane. So simply in a zigzag manner it can be represented. And what about this? This is a branched structure, as I already told you. That is, so how to draw this? For instance, when you got the nomenclature like this, 2-methyl propane. First, propane means 3 carbon atom. 1, 2, 3. In the second position, methyl group is joined. So this is methyl group. Fill up with the hydrogen and make sure each carbon has 4 valencies. So CH3, CH. So this is the way we can draw the structure. Okay. And in the case of aliphatic hydrocarbon, it can also be classified as saturated and unsaturated. So here it is a saturated hydrocarbon. Here it is the 2-butane unsaturated. Why? When there is double bond or triple bond, it is called unsaturated. They are not satisfied with the single covalent bond, and that is why they are called unsaturated hydrocarbons. So this is alkene, this is butene, and we must indicate the position of the double bond. So the position of the double bond is 1, 2. So in the second position, double bond is present. So 2-butene. Okay. So this can be written as CH3, CH, double bond, CH, single bond, CH3. You must always ensure, as I already mentioned, 4 valencies around each carbon atom. 3 plus 1, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1 plus 3, 4. So it is satisfied. Okay. Next, cyclic hydrocarbon, they are classified into alicyclic, aromatic, and heterocyclic. So alicyclic means a cyclobutane is one of the that is examples. Cyclohexane, hexa means a 6 carbon atom with the cyclic structures. Cyclohexane. Similarly, buta means 4 carbon atoms. So 4 is a ring structure with the 4 carbon atoms. So cyclobutane. This is called cyclopentane because it has got 5. So you can call it cyclopentane. So correct it, cyclopentanes. What about cyclobutane? It will be like this. How we can draw CH2, 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 CH2. Okay, so they form a cycle. So it is called cyclobutane. This is easily represented like this. So what do you call it? Cyclobutane. Okay, and the cyclopentane. So here it is represented. So let me draw here. That is CH2, 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 CH2. Okay, just join. So it has got cyclopentane. When you look at the molecular formula, it is C4H8. That is almost the molecular, I mean the general molecular formula of what? General formula of alkene. So cycloalkanes and alkenes, they have general formula CnH2n. Okay. Then what about now let us go to aromatic. So this is a benzene. This is known as benzene. So its structure will be actually that is CH. You can draw the structure as CH, C, 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 C. So all are involved like this and H, 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 H. It's a hexagon structure, a planar structure. Okay. So you can put the alternative double bond. Alternatively, there are double bond. Now you can check the valency also. 2 plus 2, 4. 2 plus 2, 4. So everywhere you can find the valency 4. So similarly, naphthalene. Okay. So two benzene rings are adjoining here. So this is the best example for aromatic. Then hetero means, as I already mentioned, a different atom. In this case, furan. So furan has oxygen as heteroatom. So this is furan. And what about this pyridine? Here, nitrogen is heteroatom. Okay, so it's a hexagon structure. Hexagon form with nitrogen as heteroatom. So let us look at this benzene. So benzene is an aromatic compound. Aroma means pleasant odor. There will be some odor. Okay. So they are that is aromatic compound, and basically they have the structure as I already mentioned. You can mention here C, 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 and then hydrogen, hydrogen, hydrogen. Okay, so this is the structure of benzene, and this can be simply represented in a hexagon with alternative double bond also. Okay, so this is pyridine. So shall we try this pyridine with the complete structure? Here already 2, 3. So you can put CH only. What about this? CH only. What about here? CH only. Similarly, CH only. Here CH only. Now you check 1 plus 2, 3 plus 1, 4. So everywhere it has what? That is CH. Okay. And here only nitrogen, and there will be a pair of electrons here as lone pair of electrons. Okay, so it involves in an alternative double bond. So there will be some delocalization of pi orbital. You know already this is sigma bond and this is pi bond. So similarly, so can you shall we count the number of sigma bond and pi bond here? For instance, how many sigma bonds are present here? That is CH sigma bond. CH sigma bond 1, 2, 3, 4, 5. So there are 5 CH sigma bond. And how many CC sigma bonds are available here? That is 1, 2, 3, 4, 5, 6. So 6 CC sigma bonds. 1, 2, 3, 4, 5, 6. 6. And how many CC pi bonds are available? 1, 2, 3. So there are 3 CC pi bonds. How many double bonds are there? Together they form 3 CC double bond. Do you understand? Alpha and beta. I mean alpha, not alpha, sigma and pi. They combine together to form double bond. Are you able to follow? And in this case, here we cannot simply put CC because there is a CN also. So you have to be very careful here. So I made a mistake. So you can correct here. That is how many? 1, 2, 3, 4 only. And there are 2 CN. So we can correct this one as CN. Is it not? So 4 CC. Okay, so we can correct it as 4 CC and 2 CN sigma bond. Are you able to follow? So 1, 2, 3, 4, and you have CN here instead of CC. So you can call it 4 CC and 2 CN. Together they form what? And similarly, what about pi bond? There are 2 pi bonds like this and only one C pi. So you can correct this one also as 2 CC pi bond and 1 CC CN pi bond. So together they form what? 2 CC double bond and 1 CN double bond. Okay, so correct this one. So pyridine. Okay. So the family of, you should know something about a homologous series. Homologous series is the family of organic compounds having the same general formula and they have similar chemical properties. They are called homologous. Okay. And homologous series have, as I already mentioned, they have general formula, same general formula, similar chemical properties, and they have similar structures. Then they have common ending. For instance, butane, methane, pentane, ethene, propene, propine, butane. So likewise, they have common suffix and they have similar methods of preparations also. So let us consider some of the examples of homologous series. Here we have methane, ane, these are the suffix. And meth means one carbon atom, eth 2, 3, prop, 4, buta, 5, penta, 6, hexa. So you combine this, you will get these. And not only that, they have the general formula CnH2n plus 2. This is alkane. They are called alkanes. So ane with common general formula. And they have, you can find the difference here, only CH2. So you just, that is, let us have C2H6, that is the ethane. Methane, CH4. Let us subtract, what will you get? H2. So CH2 is the difference. So they have the common difference between these two, CH2. And here CH2, here CH2. Likewise it comes, okay? So they have the same formula, that is CnH2n plus 2, and this is the simplified formula. And all of them have, as I already mentioned, ane suffix. So as I already mentioned, the common difference is CH2, 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 CH2. And they have the common, I mean the molecular mass, the difference is maintained here as 14. Okay, so everywhere you can find the difference 14. So the homologous compounds, they have the gradation in physical properties. Like let us consider here the boiling point. In the case of methane, the boiling point is 100 Kelvin. Ethane, it is around 190 Kelvin. So there will be a gradual increase with the increase of length of carbon chain. So that is the speciality of homologous series. You can find some gradation in the physical property. So this technical term is very important. Okay. So physical properties means that there is boiling point, melting point, all these things. Okay. And we have the functional group. This is called alcohol functional group. So you have methane, you can remove one hydrogen, so it becomes a methyl group, and add this one alcohol group, OH group, so it becomes methyl alcohol, and in IUPAC it's called methanol. So likewise it's called methanol, ethanol, propanol, butanol, pentanol, hexanol. Okay, or it can also be called by common name methyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol, pentyl alcohol, hexyl alcohol. Okay, kindly note down all these notes. This will be very useful to you. Okay, and the alkenes, they are that is arranged like this: CH2. There is no methane because we need minimum two carbon atoms to form CC double bond. So alkenes, the general formula is CnH2n. Okay, so they have CC double bond. So the starting, the first member is ethene. So CH2, how to, Eth means two carbon atom. So first put CC double bond, then you can introduce hydrogen like this. So CH2 double bond CH2, CH3 double bond CH double bond CH2. So it should be written, for instance, when you come across propene, prop means three carbon atom, write down pro and put double bond. So CH3, here CH2, here CH. Do you know how I put this number of hydrogen atom? Based on the carbon atom available. Okay. So we must ensure the tetravalency of each carbon atom should be maintained. Okay. And we can indicate the position of these double bonds also. In all these cases, we have 1, 1, 1. And this can also come in 2, 3 like that. So we will discuss this under IUPAC nomenclature separately.